Hello and welcome to the attic. I don't really do product reviews very much, but this was kind of an interesting item. This is an STC-1000. I guess there were 999 tries before this, and it's a pretty standard temperature controller. It does have two relays for hot and cold. If you want to have a egg incubator and or something like that, and you had a heating lamp and maybe a cooling fan, chicken coop, who knows, something like that. You can operate both of those at the same time. So when it goes over a certain temperature by so many degrees, the fan turns on. If it goes below a certain temperature, the heater turns on. Pretty standard stuff, time delays for hot starts and everything else. But you can imagine my surprise when I opened this up and I looked like, where is everything? And then I turned it over and you still don't see anything. Well, evidently they have some chip. It might be just one of these epoxy things mounted right on the circuit board to operate everything. But this little chip here, and I don't have my microscope with me, so I can't tell you what it was, but like 30 years ago, it was the dream of every designer to have a product that was universal. They could be, attached onto any voltage, so you wouldn't have to be selling all this equipment that like was this voltage and that voltage, stocking problems. This thing operates on AC or DC, but get this, it's operating right now on 15 volts, and this can go from 15 volts to well over 250 volts. Pretty amazing. The factory actually has this listed as 110, 220, but if you're doing battery-less things, I have a 60-volt array. You can feed that right into this. You got a chicken coop and you want to run a fan when it gets over a certain temperature. I mean, this thing's only $10, so it's like dirt cheap. You can't get temperature switches or anything like that for that price. And it doesn't need to operate when the sun isn't up, so this thing can run right off your panels, anywhere from 15 volts all the way up to 250, so whatever you have. And that's pretty amazing, isn't it? And I thought that's what was worth talking about. But the supply is right here, and this uses two 5-volt relays, and they're normally they're like 73 ohms. They're normally very hungry for current. Here's the inductor, and the reason you have this chip now is LEDs. They wanted to run LEDs from a variety of voltages, long strings of them and stuff, and this is the chip that does it. That's pretty amazing. So yeah, the outside pin is the positive. They got two diodes in here just for the high enough voltage breakdown, and it just goes into this. It's like a 3 or 4 microfarad capacitor, and here's the capacitor for the 5 volts, and that's it. The other thing I wanted to show you, and it doesn't do it when I first got this, I'm checking the ohms. So that's pretty low ohms right now. But when I got it initially, it said 270 ohms. And that's the thing with contacts, is that they can easily oxidize. So at very low voltages and currents, these can become very high resistance. If you use them a few times, they might get better. If you apply some AC load or higher voltage that will break through the oxide layer. It'll clean them up for a few years, but at some point these contacts may turn into high resistance, and you just need to remember that if it's very low signal currents you're switching, these can become bad. So that's it. I thought that was really interesting. 15 at 14 volts it won't turn on, so really you should have about you know, given variance between units, you should have at least you know, 18 or 20 volts to operate this. But yeah, any voltage you want. Pretty neat.